Hey, welcome back. In today's episode, I'm going to go through and explain to you what is blockchain. There are open and public blockchains that record transactions transparently, securely, and efficiently. The word here, open and public, this is something that is different in blockchain if you compare it to another database that may reside in a corporation or in a government. This actually transcends any corporation, any entity. It's completely open and public. That is a blockchain. It's a public ledger in which you record and commit transactions. So let's run through the typical steps on running transactions on a blockchain. So if you start from the top left, when you actually start off a transaction, what it usually happens is it gets sent to a network of nodes or computers. And why we do that? Because the majority, they need to actually agree and validate using some mathematical operation just to check on the validity of the transaction, just to make sure it's authentic and correct. And this is called a consensus mechanism. Then the block actually gets added onto the blockchain. So in effect, the blockchain, being a public ledger, in terms of how it's organized inside the ledger, it's arranged a series of blocks where brand new block that contains a new transaction gets added on to the block and so on. So you'll end up with an extremely long sequential list of different blocks held in the blockchain. So then once the change is distributed across the decentralized network of computers, your transaction at that point is effectively complete because it's recorded at that point. What are the major characteristics? I've already discussed that, one of them being open and public. It's not just an ordinary database, it's a public database. But apart from that, it's immutable and persistent. What do we mean by immutable and persistent? Once you commit a transaction onto a blockchain, it cannot be changed. Mathematically, it's virtually impossible to change any recorded transaction. This is what makes a blockchain wonderfully unique from a corporate database held in a company or in a bank, where they can simply roll back the state of a database to a previous version, thereby manipulating transaction that's been recorded. Once you record a transaction, it's kept onto the blockchain forever. We give the notion of a trust network. The blockchain is a trust network. So that's what we mean by being immutable and persistent. The next characteristic, distributed and decentralized. Well, whenever a user initiates a new transaction, then it gets validated by a network of computer or nodes, it gets distributed. The transaction gets recorded into blockchain. So every node of the network whose task is to validate transactions will receive identical copies of the same blockchain. That's what we mean by distributed and decentralized. The next feature underneath being time-stamped and audit-friendly. Well, once you've committed a brand new transaction in the block and then the block gets added into the blockchain, obviously it gets time-stamped. So in the case of performing an audit on particular transactions, becomes audit friendly to refer to those transactions by a specific date in time. So it's completely audit friendly because as and when new transactions get added to the blockchain, it becomes time stamped at that point. Blockchain has a feature that it's all controlled by what we call a cryptographic security. And this is important because it helps secure the very first characteristic listed on here, being immutable and persistent. The way it achieves through cryptographic hashing, right? It's just a series of cryptographic codes. It gets tagged to every single transaction in the block on the blockchain in order to make it more tamper-proof and watertight resistant. And smart contracts. Begin to see there are an awful lot of different blockchains out there that are mainly used to create what we call smart contracts. These are like, if you think of a legal contract that we sign when we're buying a new deed or a new property, you can effectively transpose that and convert that into a digital contract, what we call a smart contract on the blockchain. All right. So let's start off with the basics. A smart contract is essentially just a digital agreement that is stored and executed on a blockchain network. Now, these contracts execute automatically when the predefined set of terms and conditions are met. Now, the terms are written in blockchain-specific programming languages, such as Solidity. Smart contracts are foundational to many blockchain applications. Now, how do smart contracts actually work? Function similarly to traditional contracts, but are executed automatically via code. Now, here's the actual process. It starts off with an agreement where there are two parties that agree on the terms and conditions. It follows by actually creating the contract, so contract creation. So the contract is at that point actually coded, often with the help of a smart contract provider or developer. It then follows with actually deploying the contract. So it's actually published onto the blockchain, followed by monitoring. So the blockchain needs to start tracking the agreed upon conditions, and then followed by execution, where the contract executes a series of actions when conditions are met. And then finally recording the transaction and its outcome are actually recorded on the blockchain. What are the top use cases of smart contracts? So let's start off with decentralized finance, DeFi applications. Now, an example there would be where a user wants to lend their cryptocurrency to another person. So they would actually use a DeFi platform where a smart contract automatically matches them with the borrower, manages the loan terms, and ensures repayment with interest without needing a traditional bank. Another example in the conversion of assets into non-fungible tokens, NFTs, would be where an artist creates a digital painting and mints it as an NFT on a blockchain. The smart contract at that point would manage the sale, the transfer of ownership, and any future resale royalties automatically. Within the realm of supply chain management, an example there would be where a manufacturer uses a smart contract to manage its supply chain. So in this case, when raw materials are shipped by a supplier, the smart contract automatically releases the payment once the shipment is received and verified. In the realm of digital identity cards, an example here would be where an individual uses a blockchain-based digital identity for online services. So a smart contract in this case would verify their identity for service access without sharing personal information, protecting their privacy while ensuring authenticity. In the field of real estate transactions, an example here would be simple, where a buyer actually purchases the property and a smart contract handles the actual transaction. Upon receipt of the payment, the contract automatically transfers the ownership to the buyer and updates the land registry on the blockchain. So you can see the list here is only a subset of the true potential of smart contracts in terms of tokenizing these use cases onto the blockchain. And this list is growing extensively and quite rapidly. Smart contracts do represent a powerful tool for automating and securing digital agreements. They are pivotal in the tokenization of real-world assets, bringing greater transparency, efficiency, and automation to industries such as financial instruments like stocks and options, real estate property, arts and collectibles, legal documents, and many more, making this process truly accessible to every kind of investor, even enabling fractional ownership of tokenized assets. While there are challenges to overcome, the benefits are indeed substantial. That's all I have for you for today. If you value clarity on Bitcoin, blockchain technology, and real-world assets tokenization, stay alert. Subscribe and enable all notifications to stay ahead of the curve. Share this episode with those who need to understand what's coming, friends, family, and colleagues. This channel aims to deliver insight, no noise, and no hype. Subscribe now.